What actually happens if you fall into a black hole? Imagine this. You're not floating in the ocean or a swimming pool. You're completely alone, lost in space. Your spacecraft keeps drifting away. You reach for it one last time. But in space, there's nothing to push against. You turn around, and there it is, Earth. Everything you've ever known, everyone you've ever loved, is right there. Down there is everyone you've ever loved. Your family, your friends, even millions who have no idea you're about to disappear, is right there. No one down there knows what's happening. Billions of people keep living while you're completely alone. Then you remember your oxygen. Only 30 minutes left. You look at your spacecraft one last time. Then you stop fighting. You accept your fate. But then something catches your eye. A tiny dark object floating in the distance. At first it seems harmless. But then you realize you're not looking at it. You're moving toward it. It's a black hole, the most dangerous object in the universe. But before you fall inside, there's something you need to know. Not all black holes are the same. Let's assume this is a stellar black hole. It was born when a massive star reached the end of its life. Then everything collapses. In less than a second, the star explodes. But the story doesn't end with the explosion. The star's core keeps collapsing until a black hole is born. Now you're falling toward it. And what happens next is terrifying. The black hole doesn't pull your whole body equally. Your feet are pulled first. Your legs keep falling faster than the rest of your body. Gravity is pulling you apart. Your body keeps stretching longer and longer until you become a thin strand of matter. Seconds later, there's nothing left of you. Only a thin stream of matter. But remember, that was only the smallest type of black hole. Now imagine something much bigger. This time, you survive a little longer. But don't celebrate gravity is still winning. This time, you don't stretch the same way. Instead, gravity slowly tears you apart. But if it's a supermassive black hole, everything changes. You could actually cross the event horizon without feeling anything at all. Now you're trapped. No force in the universe can bring you back out. You keep falling. Minutes, hours, maybe even days. Beyond the event horizon, every path leads inward. At the very center lies the singularity, a place where gravity becomes infinite, and every law of physics we know breaks down. No telescope has ever seen it. No signal has ever escaped it. Whatever truly exists, there remains one of the greatest mysteries in the universe. Not every dying star becomes a black hole. If the collapsing star isn't massive enough, gravity compresses its core into something astonishing. A neutron star. An object only about 20 kilometers across, yet containing more mass than our sun. The most astonishing part isn't its size, it's its density. Imagine squeezing more mass than our sun into a sphere only about 20 kilometers wide. Just 1 teaspoon of neutron star matter would weigh around 1 billion tons on Earth. If you somehow reach the surface of a neutron star, the journey would end instantly. Its gravity is about 200 billion times stronger than Earth's. A single step would be impossible because you'd be crushed into an unimaginably thin layer in less than a fraction of a second. Neutron stars don't just crush everything, they also spin at unbelievable speeds. Some rotate more than 700 times every second. Their powerful beams of radiation sweep across space like giant cosmic lighthouses. When one of those beams points toward Earth, astronomers detect a perfectly timed pulse, again and again. But some neutron stars become even more terrifying. They are called magnetars. Their magnetic fields are so powerful, that even thousands of kilometers away, they could disrupt electronics. And at close range, they could literally tear apart the atoms in your body. Sometimes the magnetic field inside a magnetar suddenly snaps and rearranges itself. In less than a second, it releases more energy than our sun produces in hundreds of thousands of years. These giant flares are among the most powerful explosions ever witnessed in the universe. As terrifying as magnetars are, they aren't the final act. Every black hole, every neutron star, and every magnetar begins with one of the most violent events in the universe, a supernova. An explosion so powerful that for a brief moment, a single dying star can outshine an entire galaxy. When the explosion finally fades, the story is far from over. If the remaining core is heavy enough, it collapses into a black hole. If it's slightly lighter, it becomes a neutron star, and sometimes a magnetar. Every terrifying object we've explored began with the same spectacular ending of a massive star. So, which one is the most dangerous? A black hole traps you forever. A neutron star crushes you in an instant. A magnetar can tear apart atoms without ever touching you. Each is deadly in its own way. But together, they reveal just how extreme our universe can become. The universe isn't trying to destroy us. These cosmic giants are nature's greatest laboratories, revealing the true limits of gravity, matter, energy, and space-time. By studying them, scientists uncover the laws that shaped the universe itself. The universe is filled with wonders that challenge everything we think we know. Black holes, neutron stars, and magnetars are only the beginning. The deeper we explore the cosmos, the more extraordinary its mysteries become. And perhaps the greatest discovery is still waiting to be found. The universe still holds countless mysteries, and we've only explored a tiny fraction of them. If you enjoyed this journey, subscribe and join us for the next adventure into the cosmos. Seis ios.